Well, good evening to all of you, and welcome. I'm very happy to welcome you to our presentation this evening as we enter the 24th year of our speaker series and bringing amazing people to the college and the community. So thank you for being here. My name is Dianne Cheseldine, and I'm the founder of our Distinguished Speaker Series, and my other job is the official treasure hunter for the series. Titles aside, I love my job, and I can't wait for you to meet our latest find. Mr. Tim Sweeney. Where's Tim? You didn't leave, did you?
Right over here.
Oh, there you are. Okay. I have to learn to look around on all sides, right? So, whose passion for helping the planet you're going to experience tonight all together. And someone essential in helping me to find this treasure is also here tonight, a dear friend of mine in the front row, Dodd Hadgu, who is also, say hello, yeah, how about hello in Eritrean? Because it was Dodd who put me in contact with Mr. Sweeney. And Dodd himself is a notable architect in our community. So thank you, Dodd. And you had your own committee to go to, but you got here, so I really appreciate that. As a longtime teacher, who's counting the years, I can say with confidence that you will be inspired and learn a great deal this evening from Mr. Sweeney, here back behind me. Yes, okay. Don't go anywhere. So I do want to thank our supporters this evening, and that includes the TMCC Foundation and Grants Office for their support. And through, this was through a sustainability grant we received, which made it possible to feed you guys a little bit tonight. And the person I want to thank is here, Brianne, yes, in the front row, Lee, and thank you, Brianne, for pushing that through and helping us. Thank you so much. Where was I? Oh, thank you, our wonderful team. We have a small but wonderful team committed to our projects, and I want to thank everyone. And I want to thank the gentleman on his throne in the back, Tim Ill, who is the absolute best videographer there is. And recently he now is into drones and flying over everybody outside and taking their pictures. And so we're glad to have you, Tim. Thank you very much. And let's see, where was I? Someone very important I want to bring up. She's probably going to spank me tonight, but that is Adine Storman here. She is our chair of the committee, and she is really irreplaceable, and it wouldn't be possible without her guidance in so many areas. So I just, okay, I'm going to leave soon, so you can't beat me up. She's very modest. Oh, plus we have, you just saw it. We have a lot of tech people here to come to the rescue. You just met one of them, and there's somebody around here in case the computer doesn't work. So we have lots of people involved behind the scenes. In preparing to introduce our speaker tonight and looking over his extensive, that's putting it mildly, resume, CD? No, that's the wrong term. CV, thank you. You probably have a CD too, right? Okay. It's CV, and I thought, oh my goodness, we'll be here till midnight, and I appreciate your being here now, but I doubt if you want to hang around till midnight, so I tried to highlight just a few of his accomplishments this evening. And so Tim is CEO of Simplus, did I pronounce that correctly? Simplus Systems and principal of Sweeney Architecture. He has been providing both public and private architectural services for over 40 years in Reno and in the western United States. He is also, keep in mind, I only selected a few, a former general contractor, a structural insulated panel SIP manufacturer, an SIP installer, a co-housing facilitator, both a certified passive house designer and tradesperson, and the Nevada Sustainability Director for the American Institute of Architects in Northern Nevada. Mind you, that's a really edited bit of information. So Tim, I want to bring out the fact that he's approaching building design and construction using all the experiences and tools that he's gained over the years. And so it was with great pleasure that I welcome Tim Sweeney, and it's been a delight having the chance to meet him and talk briefly yesterday when we were in here setting all this up. And thank you for joining us, Tim.
Diane, thank you again very much. Adine, thank you again. Tim, everybody here, thank you very much for coming. I'm very pleased to be able to basically spread the word about how to build more sustainably. And let's get into a few, okay. Help. Yeah, it's not advancing. There we go, there we go. My mistake. We need to reverse climate change, and the problem is that buildings are a big part of what causes climate change, and I'll explain all of that in a minute. But let me first say that I am not a salesperson. This is not a sales presentation. I'm not a TEDx speaker. I'm not a professional speaker. This is an informational session, and I'd like it to be a discussion. So, you know, probably you can raise your hands or get my attention anytime you want, but we'll do questions and answers at the end also. So we're going to talk about how buildings are really one of the biggest sources of climate change, how sustainable buildings are really the solution, both for new construction and retrofit, what proprietary and non-proprietary solutions are available to you to use, and how everybody really needs to stop wasting all of this. It's really simple to do it right if you know how. That's what I'm here for. So climate change really is slowly killing all life on the planet. It just keeps getting worse and worse. And evidence is really everywhere. You can read the list, and you've seen evidence of this before. Some people think it's just part of a natural cycle, but if you look at CO2 emissions through the history of time, it's exponentially increasing to a level we've never, ever been able to even not only not document, but conceive of ever happening. So, as I said before, we're both the answer and the problem. But there is a solution. It is, at least to part of it, sustainable buildings. And there's some global plans on how we can get climate change to be reversed. But a lot of us don't really understand what to do about it. And hopefully that's where I can help. So, as Diane said, I've got a whole bunch of years of experience, and it all comes with time, and luckily without too many errors. So without dwelling on that too long, let's look at the solutions that we want to try to get towards. So the International Energy Agency, IEA, has come up with their 2050 net zero roadmap, and the US has their own version of that. And there are some deadlines, such as this 2031, right around here, which is only 6 years away. And to be honest, I don't think we're going to make that, because we need to have all new buildings be net zero ready by that period of time. And 20% of existing buildings need to be renovated by that period of time to be on track. By 2050, 85% of buildings should be net zero ready, and I'll explain more what that really means. But we're not going to make this deadline, and hopefully we will get it down with enough understanding and effort by everybody who's involved. This is exactly the problem. The greenhouse emissions that were in 2022, 57 gigatons. And if we keep on going on this yellow path, we're going to have our temperatures increase by 2100 to 4.8 degrees when we really need to get down to 2.7 degrees to be on this blue path and to really not have some terrible things happening. To make matters worse, the population is increasing. It's astounding to me how much growth is going to be happening, an equivalence of entire New York City every 34 days for the next 40 years. That's just bizarre, but that is what's happening around the world. And it needs to be done sustainably, of course. We've got to stop this greenhouse gas problem. So net zero, what does it mean? Well, it's basically cutting carbon emissions, which is caused by burning of fossil fuels, which is in essence greenhouse gases, cutting it down to a level where the planet can naturally absorb it and deal with it. So net zero just means getting to where we're sustainable. And we've got a long ways to go, unfortunately. But there's 4 major ways we can reduce the greenhouse gases. Operational carbon, the fuel we burn to heat and cool and run and power and light our buildings. We can cut down on that. We can reduce the embodied carbon, that fuel that's used to make buildings and make the materials and to transport the materials to the job site. Definitely there's some good movement towards clean energy and solar and such. And sequestering, capturing the carbon that's already out there and that is being produced, that's a good reason not to cut down trees and make lumber. So there are ways to redo it, and the problem is that 39% of all the greenhouse gases are by building operations and building construction. So meanwhile, the codes are not adequate. They don't really get buildings built that are of a nature that limit those fuel usages, both from construction and from operation. These are a couple of projects that have been completed recently in the Reno area. Tilt-up buildings, you use a lot of energy just to make concrete and the steel. Wood without a lot of insulation is a problem. And of course, any casino down in Las Vegas is going to burn as much energy as they can to get in the paying customer. So we've got to stop all of this waste. Now, if we didn't have leaky buildings, that would be half of the battle right there. But buildings do leak. They leak air, they leak energy, and it's likely, well, it's certainly because they don't have air barriers that are adequate to stop the moisture and air from migrating, and they don't have the amount of insulation to keep us from having to burn more fuel But as an example, one electrical outlet on an exterior wall can leak up to 55 gallons of water vapor per heating season, just one outlet. Now, if that moisture, and in Nevada, it's dry outside typically and more humid inside. If that pressure drive causes that moisture to get to a point where it can't evaporate, if the building's not leaky, well, then that moisture can collect and cause condensation, mold, deterioration, a lot of repair work expenses and health problems. So you need to have an air barrier basically on the inside of the building to stop that moisture from getting out. But then there's more to it that I'll explain about ventilation. Thankfully, people are problem solvers. We've had a lot of problems that we've all had to face, and we're pretty good at rising to the challenge, especially when it's our own dollars and our own lives and our own futures at stake. So we can tackle this problem if we really put our minds to it. But it's all, again, lowering the amount of fossil fuels that we burn. So let's talk about how buildings can be made better. And basically it's two ways: reducing the operational carbon, burning less fuel, operating them, and reducing the embodied carbon, using less fuel, making and transporting the materials. And we'll start with the operational carbon first. Remember these numbers 1 and 2 because that's really the basis of everything. So the best way to make most efficient, energy efficient buildings is with a way of designing that is called passive house design. And I'll explain how that name is a little confusing. But basically, you have the best way of designing that we're going to be coupling with the best way of building. That's the 1-2 punch we're going to be talking about. So passive house is a German word that means inactive, passive, and it also means building. So inactive building relating to the mechanical systems. This coffee thermos is a perfect example of something that's passive. You build it once, it does its job, you can keep using it over and over as opposed to having to keep pouring more energy into something. And this is actually a 26-story passive house dormitory that has been completed in 2018. Not one of my projects, I wish it was, but it's an example of you can do more than just houses. So we have here's a little story about what passive house is.
Passive house explained in 90 seconds. Does your house have a heater in the basement or maybe a fireplace? Probably also a central air conditioner or maybe a window unit. Did you ever wonder if it was necessary? In 1991, a physicist in Austria, Dr. Feist, built the first passive house. Here's what he did. 1. Proper insulation. It's just like wearing the right winter jacket, it also doesn't need a heater. 2. No air leakages. There should be no holes, small or large, to let hot air out of the house. 3. No thermal bridges. A thermal bridge is like a road for heating energy in which warmth can travel right through your walls. As a matter of fact, most of our houses have thermal highways in our walls where heat can easily travel to the outside. Plus, the house needs proper windows most of the time with triple pane glass. It needs to be oriented properly so the sun can heat it in the winter and shade is provided in the summer. And it uses an HRV, a device that provides the inside with fresh air without letting the heat out. Add all these things up, and it turns out your house doesn't need a heater or air conditioner. So where does the heat come from? A passive house needs 90% less energy, and that can easily be supplied by your body heat, the sun, your appliances, light bulbs, and even your TV. This saves you a lot of money on your heating bill and helps preserve the environment. Did we make it in 90 seconds?
You bet we did. Very good. So that talked about windows being triple pane. In this area, double pane is often adequate. And it's, as I said before, it's not just for houses. To prove the energy savings, the column right here of energy used per year, 4.7 thousand BTUs, that's basically 4.7 thousand candles per year, per square foot, is really minor compared to the way that homes are being built nowadays or are existing, 20 times more energy consumed, or even the latest codes have 10 times more energy. So you're 85 to 95% less leakage and energy use and fuel costs and pollution just by using proper design. It also makes a more comfortable, healthy, enjoyable spaces. Besides all the fuel savings, there's less maintenance, longer lasting materials, and it's just the more you go towards the right on this scale, the closer you get to net zero, to truly energy efficiency and getting rid of the way we're building today. Greater energy savings, more comfort, healthier environment. Yeah, it's going to cost a little bit more, but without any other considerations, it's worth it, because you're going to get that money payback plus, and there's ways to even save money with the construction systems I'll tell you about. So, reducing embodied carbon, the material or the energy that's used to make materials and build buildings and transport things. RS Means is the US's largest, most well-respected estimating service. They publish all kinds of estimating guides for contractors and architects and engineers. And they did a side-by-side test of a 2-story stick-built 2x6 home compared to an OSB, that means oriented strand board, it's kind of like a particle board, panelized house. And they found that indeed the panelized house was 55% faster to put up and took 41% less labor. Now that all translates to cost. And that means it's easier and there's less callback if you're a contractor. That's very important. There's lots of different ways of panelizing though. And I'm going to run through these so that you know your options and you can make your own informed decisions. So we're talking about, first of all, what's called wood open wall. And it's basically stick framing done in the factory, making panels that are the size that can fit onto trucks and go out, set it into the field, and you save a lot of time in the field, at least for doing the framing part of it, but you still have to insulate it, you still have to sheetrock the inside of it, and it's still stick framing, it's still subject to fire, still subject to mold and other problems. And typically it's done with fiberglass insulation, which often sags and cause gaps in the insulation. And every time you have a wood stud, you have what we just heard was a thermal bridge, a place where you have lesser thermal resistance compared to the rest of the wall. So even though you may say that it's an R21 wall, it actually often performs only R15. And you can have hot and cold spots. Basically, it's better than stick framing in the field, but it's still stick framing. There's another version of stick framing, panelized, which is by the company called Certainteed. They supply a lot of different building materials. They have what they call their OPA, or one precision assemblies. And that comes actually with the siding and with the windows. But and this one actually has insulation in place. They leave off the drywall so you can run the electrical and then put in the drywall inside. But it's still stick framing. It still has the same problems of that any wood project does, and there's a lot of shop labor that goes into it, so it's not an inexpensive solution. And again, the thermal resistance is really not all that great. Now here's where we start getting into panels, true panels. This is the OSB panel that I was talking about before. This is what RS Means did their evaluation compared to stick framing. And it's definitely a more energy efficient way of building because there's basically uninterrupted insulation along the width of that panel, and there's just what are called splines, doubled up studs basically that happen every 4 foot on center. So you save a whole lot of thermal bridges, and it's done in a factory. So there's little shop labor, and it goes up fast in the field, so there's little field labor, so you save a lot of money there. The cost is going to be more than stick framing, just on material basis, but you save a whole lot in time and effort, and often it's actually less expensive than stick framing. You do have to use drywall to finish off the inside of it because it is wood, unless you like the wood and you don't need a fire-rated interior, then you can live with OSB if you choose to. The other kind of SIP, or a structural insulated panel, is MgO. MgO is a chemical name for magnesium oxide. This is a sheet of it right here. It's just cement board. It happens to be made from magnesite ore. The cement most people think of around here is Portland cement, which is made by burning limestone. And so it's just a different kind of a cement board. And I can pass this around if people would like to take a look at it. So it is one of the two kinds of materials that they make MgO SIPs out of. This happens to be a sulfate formulation, and the more common one is called the magnesium chloride formulation. They're both good. They just have different features to them. But the bottom line is very, very little shop or field labor required. And so even though you're going to be paying more for materials than sticks, it's definitely, by the time you get everything totaled up, a more affordable way to go. In fact, so affordable that you can pay for those passive house increased costs and still end up with an overall less expensive building that is healthier, performs better, is more sustainable, exactly where we're trying to get to. And this is a little bit more information on structural insulated panels. You'll see it's a sandwich of insulation, often expanded polystyrene or styrofoam, and the cement boards, and then there's different kinds of splines that you can use. Metal has been used quite a lot. I don't agree with that approach because it's a thermal bridge. That means you need to put additional insulation over the exterior to stop the temperature from reaching that metal. Or you can use synthetics such as fiberglass. That's really the best way to go because the thermal expansion coefficient of fiberglass is the same as the MgO board. Or you can use wood. You better use dry wood that doesn't shrink on you. Or you can use what are called block splines or surface splines, which are kind of like what they call biscuits in cabinet work. But again, MgO is non-combustible, antifungal, fire resistant, water resistant, non-toxic, and that's an example of what happens. It just gets a smudge. And this is a mini sample of that same kind of thing. It's just has skinnier piece of insulation in here to allow people to more easily handle it in demonstrations such as this. So, wrong way. This represents two examples of using the magnesium oxide structural insulated panels like I'm passing around in projects. There happened to be two schools, one in North Carolina, one in Florida. Both of them were done from groundbreaking to students sitting in their seats with under 120 calendar days, which is crazy fast. And as you see, the contractor saved over $1 million in what are called general conditions, the overhead costs, because it was done so fast. Hopefully that went back to the owner's pocket. But these are true examples of buildings that have been done. And one of them in Florida even survived Hurricane Irma with just a couple of windows that blew out. They weren't fastened incorrectly. So even though other buildings in the area had lots of structural damages, the Florida building didn't. And if you're doing what's called prevailing wage projects, that means you're required for any project using government money on a government project or funded project to pay a minimum wage, which is often very equivalent to union wages. If the majority of your building is panelized, you save a whole ton of prevailing wage costs by building those materials in a factory, taking it out there, getting it more quickly and accurately and easily done. So, as it says, save a lot of time, labor, cost, and grief. Now, beyond the standard MGO panels, you add passive house features to them, and then you get the best of both worlds. So there's two kinds of panels that you can use that have passive house features. And there's others on the market, but these are the two that are more common. One is basically a wood double wall system. And so they have enough insulation, and often it's mineral wool, or sometimes they'll use some organic insulations. Enough insulation to get the R value they need. And they will also put on an interior air barrier and an exterior weather barrier. That's a great way of doing it, but with the wood wall panels, again, you're combustible and you have a whole lot of shop labor because there's a whole lot of framing that goes on with it. And you have to add the drywall. So you're ending up with more embodied carbon, but it's still a good alternative compared to conventional construction. Or you use the magnesium oxide SIPs. This happens to be the image of our Simplus System panel, and it'll come in large units. Very similar to this over here, except we're not using wood, we're using the MGO panels, the exterior weather barriers or interior air barriers, and it's, like we say, Legos for adults. Just set it down, glue it and screw it, and then do the next one. So when you think about all of the different building systems that are available to you, the common standard everybody uses is wood framing. And if you think about what's the most energy efficient and the least, the slowest and the fastest relative to wood framing, all of these guys may be a little faster, a little slower, but they're all definitely less energy efficient. Where if you get up into this corner, you have really 55% faster than wood and 80 to 95% more energy efficient. The double wood wall panel will be in the same energy efficient range, and it'll be just as fast in the field, but it will end up costing you a little bit more. And when it comes to embodied carbon and R values, this is really where the important things are happening. This is the amount of kilograms of CO2 that are embodied in a standard wood wall, 17.4 kilograms versus the Simplus system. And again, this is not a sales job, but I just want you to know what's available. And other people who make this kind of systems. Unfortunately, there is nobody else because I invented it. But we have less than half of that embodied carbon, which has been proven by analysis of a software called pH Ribbon, and we're double the R value of the standard wood wall. So you put together magnesium oxide-based SIPs with Passive House and our own secret sauce, and we really believe it's the most efficient way to build. This is more of the same. Roof panels, sitting on wall panels, sitting on floor panels, all of them done with the same Passive House and magnesium oxide approach. But 20% less framing costs. It depends upon how much of your building is going to be built with panels as to how much money you can save by using these kinds of systems. We're about ready to go to a building department on a Virginia City Highlands home, and we're using panels for the roof, interior walls, exterior walls, floor systems, 2 stories. Foundation is the only thing that's not panels, and it could be, but we're dealing with rock situations, and so it's best to use concrete. But the bottom line, and that one is coming in at 20% less construction cost than stick framing. So, but the bottom line is, for example, if you have a $12 million project, you can save somewhere in, say, 1.33 million. That's a 10,000 additional free energy efficient space that is available that can be put to whatever use you have, whether it's housing, whether it's any other kind of building. Dollar per R value is what it all boils down to. 64 cents a square foot a wall area for our system versus a code wall versus a double wall. And here's standard tilt-up concrete and concrete block. Trouble with the concrete and block is typically they only put 2 inches of rigid insulation in them. And you need typically scaffolding and cranes and more equipment to get those things built. Often heavier foundations, more earthwork, more reinforcing, more concrete. This is a light system and you can avoid a lot of those problems. So you take what used to be 39%, and we believe we're down to 7% or even less, depending upon the project and how much of the building is made with this kind of a system. And again, the choice is really of many different systems, but it's up to the owners to determine what is really best for their needs. So let's see what the rest of the world is doing, especially regarding passive house design. I showed you this dormitory, 26 stories. Well, yes, it is panelized also. I bet they use metal studs in here, but I would also bet that they have a lot of insulation on the outside to compensate for that. So dormitories are definitely easy to do. This is a multi-family high-rise building that's about ready to start construction in Vancouver, all passive house. Whether it's panelized, I don't know. Multi-family, in fact, it's actually has commercial on the bottom, so it's called mixed use. Office buildings, the fact that they can get by with all that glass means there's a whole lot of insulation someplace. Affordable housing, elementary schools, colleges, resorts, historic renovations, historic or even non-historic renovations. You can retrofit the interior with the same kind of passive house approaches. They're not as effective, but they do work, and you will definitely reduce the amount of energy usage. The trick, of course, is when are you going to have the money to be able to put into place those changes? And that's why things are probably not going to happen on that International Energy Agency timeline. Or exterior retrofits, as this European building illustrates. It's called an inner fit. The PH, of course, relates to passive house, and it's an energy retrofit. There are new building codes out there that are available to use. They haven't been adopted. I understand that the City of Reno and Washoe County are looking at their planning and regulations and their codes. Hopefully they're taking a look at this. I would expect so. There is a study that's been done by a company called EMU that looked at all of the building codes and building standards across the nation and found that indeed the passive house way of doing things is indeed the most energy efficient. Excuse me. And as this says, I'd like to point this out, the report covers how current building codes fail at delivering resilient and healthy buildings. It's more than just burning energy, it's making good environments. And by the way, copies of this presentation will be available to those who want it. There are local sources of funding, incentives, and tax relief programs, at least directions that you can find from Kirsten, a great lady. She also can help you with learning what to do about federal tax incentives. Let me go back for a minute. I want to mention that Nevada Clean Energy Fund is her organization, and she's building one heck of a group of people to really help redirect where Nevada is going. Okay, federal. So we're getting to the bottom lines. My personal recommendation is, yes, let's get the codes going to where they need to be. Let's limit greenhouse gases. Let's promote better living and working environments for health and sustainability. Let's get some strong tax and rebate incentives going. Well, there's your political football. We're going to have both sides debating who's going to be able to do it and who's not going to be able to do it, unfortunately. It'd be wonderful if we could reward carbon reduction practices with tax and other rebates. And if we could actually penalize people who are not carrying their share of the load. So we all need to be responsible. If we're going to be building, if we're going to be retrofitting, we need to do it the right way. That goes for owners and developers, all professionals, code people, everybody. We need to be the adults in the room. So now you know ways to build more efficiently. You know how to do it with passive house design. You know how to do it with factory panelized buildings. All these benefits come at about the same cost as for what we're paying for construction right now. So why would we not do it this way? Well, everybody's used to doing things the way that they always have, and everybody's in their boxes, and it's like trying to steer the proverbial battleship. You know, it takes a long time, but we don't have a long time. So before it's too late, do what you can do. Let's take action. As I said before, our futures depend upon it, and especially our children and our children's children's futures. And it's up to you. I'm trying to do what I can do, but I'm just one person, so please do what everybody can do here. Now, I want to mention TMCC has a great architectural program. They are moving towards accreditation of their entire program, And they're really going to be the first architectural program ever, I think Daisy can maybe clarify, done at a college, a community college level.
That is correct. We have currently run the program. This year, we have for the first time the fifth-year students from the program, so we're very proud of them. Our main objective here is providing quality education to our community here in Reno, Nevada, and accessible economically for anybody who would be interested in architecture. So this is a work in progress, so we're currently working towards accreditation, as Steve was saying. And we enjoy you guys being aware of our program and sharing the word out there.
I should have handed you a microphone, so I apologize for that probably not being able to show up on the recording, but the bottom line is it's definitely going the right direction, and everybody needs to support it because they know what they're doing. And there's information over here on the table, both for the TMCC program and for myself.
Let's see,
Dianne?
you ready for Q&A?
Yeah.
Did everybody hear what Daisy was talking about? Okay, good. Didn't want you to miss out on that.
Yeah.
Ready for Q&A?
Sure.
Questions?
Yeah. So,
We do have a,
yes,
Should I use the microphone?
please.
I'm coming, Jessica.
Thank you. When you said that you invented the system, the Simplus system, I just wanted to clarify, is that specifically the magnesium oxide paneling, or what was the part that you invented? Because there were the other buildings that you showed us around the world that either had or did not have paneling, but were all passive housing. So what was the specific part that you invented?
Right.
I was interested. Patent pending, you said.
Yep. Well, as you saw from one of the first slides, I've got a whole lot of different kind of experience. And I've spent several years in the magnesium oxide panel industry. And then when I became a passive house designer, I recognized all of the passive house people don't know about panelized, panelized construction. Architects don't know about panelized construction. And conversely, all the panelized people don't really know about passive house design or even architecture. They just know how to make panels. So I realized 1 + 1 can equal more than 2, and I said, well, here's a natural. I'm integrating both design and construction processes into one building system. So it's really bringing passive house into working with panelized construction. And it's not rocket science. It's really very simple. But I'm the first one who's been able to do it. As far as I've checked, at least around North America, nobody else is doing anything similar. Everybody's still doing stick framing, and they are, as far as I'm concerned, missing the boat. But you know, everything takes time. So it's my creation. I've built a team to help us bring it to the public. We're now looking at 2 potential projects that could drop in our laps any minute. A multifamily housing project in Texas, which, you know, like senior housing and such. Plus, northeastern Nevada has a whole big problem with housing, and the governor's office of what do they call it? GOED of development put us in contact with the Northeastern Nevada Regional Development Agency, and now we're working towards bringing housing to Northeastern Nevada. It's probably going to be a combination of single family and multifamily. People are recognizing this is going to work for them, and they're contacting us, and it takes time to get it to happen, but you know, step by step, I think we're setting the standard. So hopefully that answers it. Yep. Other questions?
How do the panels work together?
I'm sorry?
You want me to go ahead?
Yeah, you've got the mic, I guess.
All right, sounds good. Efflorescence leaching is what comes to mind with a high, moisture exposure, whether it's a high moisture environment or any kind of high moisture exposure. We get a lot of that with concrete precast panels. So have you experienced any of those with your MgO, magnesium sulfate, or magnesium chloride panels?
Are you talking about the historic leaching problems that have been that did occur with some magnesium oxide panels?
That's, I read that
Yeah.
in a few articles.
Yeah,
And it's a constant problem with experience with concrete precast panels.
yeah, nowadays that problem doesn't exist. The formulations for magnesium oxide boards, as long as you're dealing with some reputable supplier, are really proven. And to let everybody know, at one time, there have been some instances where high humidity conditions caused some magnesium oxide facades to develop tears on the inside of the wall panel, and it actually was a facade, and it was allowed to leak down, and they found it by the fact it was rusting some of the steel down below. And that caused quite a lot of concern, especially since that rust could also be happening to the screws, and it also could be happening to the metal studs. Thankfully, the manufacturers have changed their formulations, and that really is not a concern. With the magnesium chloride board that I passed around, which is, this more of a white colored board, that they still recommend using corrosion resistant screws, either coated screws or stainless steel. And most of these manufacturers are providing the right screws with their systems. So it's just a matter of selecting which board you want. The gray board that I passed around, the sulfate board, that's one of their claims is that there's no corrosion risks. But really, with either of them, they're really safe and reliable. Is that answering?
Yeah, and most importantly, does that actually have any impact in your transitioning from like the sulfate boards and chloride boards to the magnesium oxide boards and the patent, the pending patent you have on it?
Our patent pending part is not so much related to the panel itself, but what we do to the panel. And I can't get into those kind of trade secret things right here, but it's a way that we both integrate, improve on panels and improve on the passive house design. But it just, how to say this?
With the sidebar.
It all works fine, and there's no concerns about any problems with either of those materials. So, okay. Hopefully that answered okay. Not quite. I guess maybe I missed the point.
It's all right. I'll reach back out.
Well, yeah, please contact me. Anybody contact me about any of these.
I was wondering about the ceiling panels or the roofing panels.
Yes.
Are they interlocking, or do you go with a conventional finish on the roof afterwards? Or?
The traditional way of connecting panels is to use these splines like the tongue and groove that comes over an element and it glues and screws to that. There are some systems out there that use interlocking lever devices, kind of like a freezer cam lock. We have that available also, as well as some other proprietary things that we're still getting through the patenting process. But the thing about anything that's spanning horizontally or close to it is how far it can span with the structure that you can build into the thickness of the panel. Typically, if you put splines at that 4-foot center, well, let me clarify a little bit more. a 4-foot wide by 8, 9, 10, or 12-foot tall panel is your basic panel. However thickness you want for the insulation or what structure you need to put into it to help it make the span. But you can also, what they call, gang them together in larger groups of panels as big as will fit onto a truck, say nominally 8 foot wide by up to 40 foot long. So we have, I say we, the company I used to be with has built panels that are 8 foot wide by 33 foot long that clear span from exterior wall to an interior wall for classrooms in a school. And those panels were, I believe, nominally 12 inches thick. They probably could use more insulation for some climates that happen to be a Florida location, so that was okay. Yeah, the standard way of connecting them is just glue and screw them together, and that's what was used in those schools. And am I addressing the question?
Yeah, I was just wondering, would you go through all the black paper and the roofing tiles or something like that on top of it, or?
Oh, as far as the actual roofing material, how you apply that? Well, you can screw into these boards just the same as you can into drywall or into wood. They hold a nail or a screw very well. There's actually a sample I was going to bring that I didn't, but it was a sulfite board, and they used ring shank nails and shot them into the boards, and they worked beautifully. So you don't necessarily need a wood top surface on a roof, but often that is what is done just to get your nailing nice and easy, because people feel more comfortable with wood. So often that is what happens on a roof panel. And then it depends upon which kind of roofing system you're using, whether you just go with a exterior weather barrier or 30-pound felt or ice and water shield or furring strips, and any combination of those materials. And it depends upon what the roofing manufacturer wants to have. That's basically how you select your roofing product.
Well, first of all, thank you, Tim. This is fascinating.
Well, here comes the microphone.
Anyway. Oh, thanks, Dianne. But thank you, Tim. This really is fascinating. A couple of questions, because I'm always thinking of systems when we bring in new products that are designed with the hope of helping our environment. So the first question is anybody studying the impact on human health of these materials? So if a material, if we're breathing it in for 10 years and some of it is losing its integrity, is anybody studying what can happen? And then the most recent example is the Philips sleep apnea machines, where the foam was disintegrating on the interior of the machines, and after 15 years of using it, some people are getting lung cancer, and it's really horrible. So that's the first question. Studies on human health using more magnesium or whatever it is. And then the second question is, when you think of the manufacturing process of these materials, are there trouble spots that you see where there is a disadvantage to the environment that seems to be a little bit more disadvantageous than trees, because trees are around us, right? And we're right. So those are my two questions.
Okay.
Thanks.
Well, to address the first question of toxicity, if we're talking about the magnesium oxide boards, it's inert. It doesn't off-gas. There's nothing. In fact, I take magnesium tablets every morning with my vitamins and such. But it's actually a beneficial, and it's actually antifungal also, so it will stop any mold from occurring, at least on the board itself. So there is no outgassing that happens from a panel, because it's basically encapsulated on the sides with the the magnesium oxide, and they are not impermeable. They will allow slow permeability, but you have that board glued with a layer of adhesive to a core of styrofoam, and I've never heard of any outgassing problems that were existing. I think by the time the glue cures and the product gets to the job site, everything is inert and no problems. So from a, I'm sorry, remind me again of the second question.
Data study research.
Well, and so the first one is anybody, and I was thinking of, we've got our wonderful partner right next door, the Desert Research Institute, and there may be a scientist who would love to study this just to
Great.
double check, I guess, I'd
love to have
because
that
I'm not
help.
right. And then, but the second question really relates to the supply chain and how the materials come together in the manufacturing process. So the most recent example of that is lithium batteries are great, but they take a lot of water to mine that lithium, and water is a scarce resource, and it's going to be it is one of the major issues of climate change currently.
Yeah.
So there's a downside to lithium, even though the upsides probably outweigh the downsides, right?
Yeah.
So is anybody looking carefully at the supply chain and how everything has to come together, and what's the environmental impact of that?
The supply chain is really, call it the biggest red flag, because right now all these magnesium oxide boards come out of China. Now, everybody thinks you can't rely upon the quality because somebody could be changing the formulation or shipping you something that you didn't order, and that's a legitimate concern. So what is happening in the market right now is that people who are the manufacturers of the panels are buying from importers who have their own standards put into place for the manufacturing. They're typically big companies that do their own in-China testing and evaluations as things are being made, checking again before things are put onto the boat, and then checking again when it gets into their warehouse. And if there is a problem, then the local manufacturers will go to the US or Canadian suppliers and say, you've got to deal with this. In the meantime, ship me new material. I'm not going to take it and wait for something to come all the way from China. Now, the little known fact is that Gabbs, Nevada happens to be the US's largest source of magnesium products in the US. There's another parallel up in Canada that is near Calgary, and there's people, and I'm one of them, who are looking at possibly developing domestic sources. I think it's just a matter of time until that happens. As long as nothing happens in the supply chain, we're okay. If something does happen, there could be a problem. And at the same time, people are inventing more sustainable products all the time, and there really could be an alternative to magnesium oxide available very soon. For example, the 3D printing that people are doing, they're using concrete formulations, and they're even doing formulations that they can do up in space on the moon and other planets, where they're taking dirt and making their own concrete. So far as I know, they have not been able to do the insulation side of it. But what it's leading me to is that there's going to be other materials that are coming out that will be used. Maybe after a while, we won't be using panels. Maybe we'll be 3D printing everything, or maybe we'll be 3D printing panels. Don't know, but it's like the Ford automobile. People are working their way through all the bugs, and eventually we'll get it all right. But you've got to deal with what you have to deal with as you progress towards the future. So.
Anybody else? This is your chance. Yes, and then Jessica, right? Yeah, thank you.
So following up with the question from Dr. Hilgerson, I wanted to ask about closing the loop on the circular economy and what is the afterlife of this product?
Great question. For those who are not familiar with the term circular economy, that means basically not making buildings and then tearing them down and then building a new one in its place. It means reusing those materials, either repurposing or moving and relocating or recycling, other ways where you're not constantly consuming building materials. Again, I don't want to get into some proprietary things, but we do have ways of making panels that can be relocated and reused. We haven't had anybody who wants us to do it yet. That's part of the problem. But the magnesium oxide or chloride or sulfate boards all can be ground up and recycled and reused for new materials. The styrofoam is a little tougher, but styrofoam manufacturers will take that material and use it to make new material also. Again, it's like getting the Ford automobile going. It's one step at a time, and we're trying to accomplish those goals, but so far it's just getting the basic package going right that everybody needs for now. But that's where we're going. You got the right approach.
We have at least one more. Jessica, yeah, you're second. You get 2 questions.
Oh, good, because I have 4. Sorry. Well, one of them was about the styrofoam and the kind of the carbon footprint of that, since being used in insulation. But can I ask you 2 quick ones first? You said the nails and whatnot that are put in there, those don't act as thermal bridges, right? The way that you do it, because of the glue, it doesn't.
Well, if you nail into this, the nail is only going to go partway into the assembly, and the insulation will then stop any conduction between that and any other nail, because the panel is thick enough that those nails will never be touching. It's only the splines that you use to connect the two together that will be conducting. It's just a matter of what they're made out of. So if you use the MGO spline that is basically a small panel inserted into it, it still has the insulation in it. But if you use metal, you definitely have a problem. You have to then really all the way through conduction with those screws. If you use wood, you have less than the metal, our thermal resistance. The foam resistance is about an R4 per inch, and the wood is about an R1 per inch. So there is some thermal bridging that happens with the panels, but they're still a lot more efficient than if you have studs every 16 or 24 inches on center. You were mentioning something up first about.
It was about the styrofoam. I mean, I was just about that carbon footprint. But I mean, if we're running out of time, I was more interested in. I mean, maybe you can address that quickly. But I was also just interested in, because you mentioned that obviously there's some proprietary secrets of this. Heaven forbid, something happens to the company or whatever.
Sure.
How is there a plan so that this knowledge doesn't get lost to humanity, like the rose window in the Notre Dame Cathedral that nobody can recreate, or Vivaldi's violins that nobody quite, not Vivaldi, Stradivarius. I should know that one. Thank you. Yeah, I mean, how is there a plan for this?
Let me first talk about the insulation.
Okay.
It's been found that, and we would love to use something more organic than styrofoam, because you do have to use carbon to make it. But we found that the amount of embodied energy that's actually in styrofoam and the thermal resistance that is present in it today is a lot more beneficial than the amount of insulation that it takes and the amount of embodied carbon for these other materials. So it's really the most efficient way of making a panel is to use foam that's available currently. Now, expanded polystyrene doesn't use that much fuel. It uses a pentane gas to expand these beads. It doesn't use a lot of other gases, but there's other kinds of foams that are a lot more energy embodied. So styrofoam's still the best way to go. And it's from a R value per benefit, it's really where you need to go, at least today. When they come up with some insulation that is affordable, that can be pressed into a panel that has organic properties, I'll do that all day long. Now let me see if I can remember the other question. I'm sorry.
Proprietary secrets not getting lost to humanity
Yes,
as knowledge,
okay.
if anything were to ever happen.
Well, it comes up to the fact that I'm trying to spread the word about the basic MGO panels plus passive house design, and anybody can do that. That's non-proprietary. I encourage everybody to do that. That's the way buildings should be built in my mind. Now, as far as proprietary secrets, those are property of our company, and our company has younger people who are in the company that have title to it also. And so it remains to be seen. You know, we may be purchased by somebody at some point, and that may be some big company, and it makes it a lot more available for everybody. But it's not rocket science either, and I think that there's other people who are going to be coming up with their own proprietary systems using the basic passive house and panelized approaches, and great, go do it. We each will have our own Ford or Chevy or whatever, but still there'll be better ways of building than what's available right now. So I don't see any limitations just due to proprietariness.
Thank you.
Yep.
Did you get all your questions in?
There was one more, but you said time was running out.
Get hold of me.
Is it short?
It was just about a slide. Yeah, it is short. There was a slide that said by 2030 or something, like net zero ready, something like 20% or something. But then farther in the future, 30 years later, no, it was like 2020 and then 2050,
2030,
85% net. So I wasn't sure because there was one slide on the slide it said, like by one date that was closer in time, all buildings had to be net zero ready, and then 30 years later, 85% of them had to be net zero ready. So I was confused about why all of them had to be ready first and then only 85% farther into the future, and I didn't know if I just misunderstood the slide or...
Yeah, it's complicated, so... Here.
There it is, yeah. All new buildings must be net zero ready by 2030, but then by 2050, 20 years after, only 85% of all buildings instead of all new buildings. That was the missing piece. Thank you.
Yeah.
Okay.
Yeah.
Thank you.
That's
Okay.
exactly the
buildings.
distinction.
Thank
This is
you.
all
That's what it
buildings,
was.
new and existing.
I didn't memorize
Yeah.
it properly. Thank
So-
you.
And that's out here at the 2050, but we're trying to at least get some of them done by 2030, and it remains to be seen what'll happen. Yeah. But good point. Yeah.
Gosh, this has been wonderful, Tim.
Thank you.
I imagine everybody joins me in being so happy to learn a little bit about what you're doing, and I really think it's wonderful that what you are doing. So, and we're fortunate you're here in Reno, and thank you for all of that. Everybody agree?
Thank you very much.
Good.
Thank you.
Thank you so much. It was so informative and also,
Well, spread the word, please. Yeah. There's-
yeah, please, yeah, exactly. So thank all of you for coming, and I imagine if anybody has something else they'd like to talk to Tim about, I imagine he would be free for a little while.
You bet.
if you
And
like.
there's
And-
information on me on the table
Oh, the
also.
information on the table, yeah.
And for the architecture program.
Okay, and thank you for being supportive of our program here
You
at the
bet.
college. We're
Yep.
very proud of that, and the fact you brought it up, the only, I believe, community college in the country who's got that program, right? So we're proud of that. And so thank you, everybody, for coming, and we will be in touch.